new document right here. So if you have code like 22,000, you can go right here and put that inside of parentheses. I don't know. That's a good question. And I'm further over. I thought I didn't hit the camera this morning. So right here, question 7 on the homework would be great if you go over, you bet. Could you go over arguments in question 7 and get tripping up? You bet. Let's see here. Let me grab a new version of this right here. And so let me grab numbers. Here we go. And let's go grab 474. And let's grab this right here. So let's take a look at this right here. Okay. So I don't know. We'll figure out the whole Twitch thing here coming up. And let's take a look at this right here. So question 7. Oh no, it's called question 8. Okay. So it is question 7. It's labeled question 8 right here. So what do we have going on right here? Create a subset called sub of students whose ACT scores is at least 32 and who are the youngest child or the only child in the family. Keep only the columns ACT, family, college, GPA, and gender, and pet. So with this right here, you will work with the sub data frame for the remainder of this problem right here. Print to the screen and verify it has this many. So let's try doing the subset step by step right here. So when we do subset right here, we need to understand it first takes in what are we subsetting right here. So it has what are we subsetting. The first goal right here is what are we subsetting. So with what are we subsetting, what are we subsetting? Who knows what we're subsetting right here? Let me clear out my global environment. What are we subsetting? And this runs all the code above. So what are we subsetting? What are we subsetting? What is the thing we're subsetting right here? What is the thing that we are subsetting? Any ideas on what we are subsetting? Any ideas at all? No ideas. Who knows what we are subsetting right here? Who knows? What are we subsetting? There's silence in the chat. What are we subsetting? Alan, Jake, Amber, Campbell. There's silence. I worry when there's silence. So that's close. Look over here, and we're subsetting a certain data frame. We're subsetting a certain data frame, so we need to subset the education data frame. And one thing I'm going to do right here is I'm just going to put education here, and this will print the whole data frame to the screen. So if you notice right here, we get the full data frame when I print it. This is not a subset yet. It's the full entire data frame. So with the first ask, what are we subsetting? What are we subsetting? So this is what are we subsetting, and we are subsetting education. So with subsetting education, yep, now we need to do conditions. So the next step here is to go in and do conditions by doing the following. We have here that we have ACT, family, college GPA, and we want at least 32 GPA. Now, we code in, everyone knows it, little bits. So let's do this right here where ACT is greater than, and I think it's just lowercase ACT, it's actually helping out, is greater than or equal to 32. So you see the ACT needs to be at least 32, and let's give this a try. This should only give us people who have ACTs of at least 32, and this is a big data frame, but if we go to ACT, does everyone see the ACTs now are at least 32? If you just look at this ACT column right here, sorry about that. If you look at this ACT column, it is 32 or more. So we have at least 32 as the ACT right there. Now we're going to do another condition. So now, how do I add in another condition? What should I put right here to add in another condition? Who knows in the chat what I'll put right here to add in another condition? Who knows? 2 seconds. Who knows what we'll put in the chat to find another condition right here? Who knows what we'll put in the chat to find another condition right here? Any ideas? We need to put in some sort of logical thing to find another condition. You're right, an and right there. So with the and right here, we get another condition that we're putting in. So at the end, let's go ahead and take a look at this. We want, and who are the youngest child or the only child. So we want a youngest or only child now. So let's go right here and go to family, and family right here. We will go to, with family, let's go to family equals youngest. And with this right here, we have to make sure youngest is in quotes. So there we go right there. And let's make sure this runs. The biggest thing, it didn't run. That's a big problem right there. So we have family equals youngest. Let's take a look at the child setting right here. And it is, we need to look at what the question says. Family. Oh, we do have it as family. Let's take a look at the headings on the education, the call names. And let's go to education. So I believe it is, which one is it? We want that they are the youngest or the only child. So like here, let's take a look. Who are at least 32, who are the youngest, or it says youngest child. Oh no. Youngest child. Let's check this out. Still doesn't have, would you need to put education? So it should just be the way it's spelled. Is it lower? It's right here. And you know what we can do to check it out? We can go to education, $. Oh, that might be the whole thing right there. And it's this right here. Look at that. That is how it's spelled. Perfect. And now we've got it. So now we have that they are the youngest child, or, let's do this right here, or the family is equal to the only child. And I think it said only. My CUD doesn't do that. Let's take a look right here. And the only child. So we also want or only child. So with this right here, we have the only child also. Let's take a look at only child. Where is only child in the data set? Youngest, here we go, only child. We found an only child. We got this. Let's take a look at only child. And there we go. We have now only child and youngest child. We have this complete in the data set. Everything is excellent right there. We have a data set of people who have an ACT score of 32. They're either the youngest child or the only child. With all of this stuff right here, let's do this on. Continuing on, let's take a look at the next thing. Keep only the columns. So now we only want to keep certain columns right here. And the best thing we can do is just copy all of this right here. Let's go ahead and copy all of this. And we need to do an additional argument right now. So the additional argument is going to be a comma. And that's the biggest thing we can say, is that we need to do a comma, and then these need to be strings. I think that's where people make mistakes on this, is that for these to be strings, can you help us? You bet. 6F, we got that next. We will do 6F next. Let's take a look at 6F. And if you notice, the color change right here is very important, that these become strings, and that's what we do. Now, we do have some other issues with this, that this is not a vector right now. This needs to be a vector here, and then we need an additional argument. We need to go here and do select to select these columns. So we're going to select these columns right here, and it's not showing it, but we should be all right. We should be fine with this. It should fix itself. Let's find out if it works, and it did. So you know what we're going to do? We're going to drop this in the chat right here. We got this. It's going in the chat. So I think I see 6F and 5, you bet. And then let's go here and go sub and store it into, and we've now stored the subset. 6F has been your worst nightmare? No! Would we not use select to pick those columns? Yep, that's what select does. Select picks the columns out for you. Great answer right there. Select is just going to only take those columns. So when you go down here to the subset, it takes just those columns. So subset takes only those columns right here, and that's what it does. So that's excellent right there. And we've created the subset. So if you notice right here, the way we've coded this, I think this is very important to do. I think you can go right here and do that. Yeah, that should work the same. The sub is 64.5. Let's take a look. 64.5. And you can separate all your conditions right here. Someone is either has an ACT score of at least 32, and they are a youngest child, or they are an only child. So this right here is a great way to make sure you kind of separate out your code, and you can see here that this is your first argument, your second argument, and your third argument right there. So all of this right here, will we not use, I think we got it. Now we've got 6F. Is this 6F for, we got to do 6F. Let's check out 6F right here. Find the fraction between 0 and 1 of whose students whose college GPA is at least 3 do this with a combination of which and length. So let's do this right here. Let's see the combination of which and length that'll get us the values we're looking for. So we're going to use the college GPA vector right here. Let's go to education and go to college GPA, and we can see all the college GPAs right there. So with this right here, with the college GPA, we want a college GPA that is at least 3. So we're going to go right here and do at least 3. So this gives us a logical vector now, which is going to be trues and falses. Now, we want the percentage. So it says to do it a more complicated way than we have to do it, but find the fraction of whose students whose college GPA is at least 3.0. Do this with a combination of which and length. Here's the easiest way to do it. You ready? This like makes it super easy. So it's like, we can just do it this way. We go here to mean, and that's the answer. That's the easy way. But if we do it this way, what will this get us right here? What will this get us right here? And what will this get us right here? So this code right here finds the mean amount, or that we'd say the percent of people who meet the condition. So that's the percent of people who meet the condition right there. And then this code, and we can do 6G next, you got it. So this code right here on line 289 is going to get us what? So the line on 289 will get us the people, so it's a which. So education, college, GPA, this is going to get us the positions of the people who meet the condition. So the positions of the individuals who meet the condition. So these are the positions of the people who meet the conditions because it's a which. So when we look at this right here, it's important we know what this code is printing out to the screen. These are all the conditions, and it's giving 12 warnings. Sure, why did it give 12 warnings? Okay, that does that. I think it was graphical warnings. It's fine. So with this right here, what does the length give us? Well, length is the length of the logical. And we could have done this a lot of separate ways right here, but this right here is going to give us how many observations there are in this. And check this out. Combining these together, I think this was 6F, right? Let me make sure this is 6F. Yeah, 6F. I put it under E. Whoops. Go right here and do the following. And so with this right here, when writing a sequence with multiple arguments, like a sequence, does the order that you write in matter? Yep. You have the default order right there. Oh no, what did I do? Length of this right here. We shouldn't do this. What am I doing? What has happened? So this right here, let me highlight this code. That gives that. And length of education vector. That's that. Oh, wait. Oh, I think I know what it is. Wait. Do we have to do... Yeah, we have to do like the length here. It's really a long way to do it. There we go. That's got it. It's a much longer way. If you notice, the answer comes out the same way. So much longer, much more work, but it gets you practice at using which and length and knowing how to do it right here. So understanding the differences with the which and the length is very important. And we won't always use it, but it's good to practice and understand how to use this right here. All of this great stuff. And I think the next question was, let's continue on to the next question because you were close. Oh, that's awesome. Let's continue on to the next question, which I think was, can you do this argument and get the same output? Length, which, and then I see it right there. Let me grab that in the chat. And that argument is, you're welcome, Raj. You the man, Raj. There we go. Got it. Let's take a look. Oh, we're missing something. So that gets you how many. And so that's it right there. And then you could divide by the number of rows. And you could divide by the number of rows in education. So that's another way of doing it right there. There's always like 5 ways to do something. So if you do it right here with this, you can divide by the number of rows. And that's pretty much how to do it. Lots and lots of ways right here. Then I think people were saying which one? 6G. Print to the screen the values in the 1st, the 5th, the 12th, and the 123rd and the 146th. Then output this as a data frame with 4 rows and 3 columns. So print to the screen the values in the first is columns, rows. Then output your command is a data frame with 4 rows and 3 columns. So where are we getting the columns? Haha. So with this right here, you need to turn these into vectors immediately. And let's take a look at how to turn these into vectors. How am I going to take this information right here and turn these into vectors? What am I going to do to turn these into vectors? What are we going to do to turn these into vectors? What will we do to turn these into vectors right here? What will we do? Any ideas on how to turn these into vectors? Who knows? What could we possibly do? Who knows? This is the big part of this question. It makes it a lot easier if we turn these into vectors right here. Who knows? We need to turn them in a vector with the close. We'll use that in a moment here, but we're going to use C for the moment to vectorize these. So we want those numbers to be 1, 5, and 12. Yep. And then we've got a vector of, let's say, the columns right here. And that's how we'll turn this into it right here. And then let's go to the rows. And the rows will be vectorized also. And there's the rows vectorized. So we've vectorized the columns, we've vectorized the rows. And I think, yeah, Raj, you basically have it. Raj has it in a little, like, another way of doing it, because we can go to the education data frame now, and we can just pick the rows we want, and we can pick the columns we want. So everything Raj has there is the same because we've already assigned to the rows and to the columns these vectors. Just to make it look a little easier, you can see the differences between the two. Well, that's the columns. There's the columns. And then here are the rows. So same output will be obtained from both of these right here. We have the rows, we have the columns, and we get the same output on both of these. So you can take a look, same output, give you your, you got it, Raj. You got it, Raj. Anytime, man. You got your degree right there with that. I love it. I love it. And so what other ones were people thinking about? What other questions did people have that we can go over? I saw quite a few more in the chat. We did 6G right there, talked about how to do it. Can you do number 5? I think, is that 5 for 320? Is that going to be 5 for 320? So right here, we want to look at certain objects. Is this the one we're looking at here? Looking at certain objects for 474. And go, oh, Sylvia said C. We'll do C right here. What are the last 5 entries of the height column? What are the last 5 entries? We're going to use Control-Alt-I to insert a chunk right here. So what are the last 5 entries? So what would we use to look at the last entries? Like what function allows us to look at the last entries of a column? Like what function will allow us to look at the last entries of a column? What function will allow us to look at the last so many entries? We covered this say in 474. What function will allow us? And we want to go to the education, we want to go to height, and we want to look at just the last 5 entries, which we should see these are the last 5 entries. So we can kind of get an idea of what the output should be. We can be like, okay, I understand what the output should be. No, I meant C for creating the vector. Oh, great job, Sylvia, right there. You are right. And so this one right here, I'll finish it off. No, you're right. And Ellie, great job right there, Ellie. And the second argument is how many do you want? So good practice right there. Great job. Great work, everyone. 100 points, everyone. You are correct. That is, and so it is C to create the vector. I was like, see, I don't remember someone saying 6C. And then I think we had a question on 5, which is going over the classes of certain types of variables. And the important thing about class is it tells us how R views this object. So when we think about how R views an object, the way R views an object controls the way it manipulates it. So if something is viewed as factor, it's categorical, and we'll get things like tables when we do summary. If something is viewed as quantitative, when we do summary, we'll get the mean, we'll get the median, we'll get all that good information right there. So let's take the object education right here, and we're going to look at its class, and let's look at it. It's a data frame. So with this, loaded from the global environment, and we have iris species. So we want to do mean also. And let's look at mean right there. There it is right there. It is, that's a lot. I might have other things stored in. Oh, maybe I do. I think yours should say it's a function. So yeah, mine might have other stuff loaded up right now. Can someone run class on mean and tell me what they get right here? What do people get when they run class on mean? You're welcome, Raj. Anytime, man. Anytime, Raj. Anytime. I don't think you're supposed to get what I'm getting right there. So I'm like, oh man, that is interesting. QG3B, you got it, Jake. You got it. And I'll do the rest of this question right here. 5B and 5C when it says object movie not found. So the movie data frame should be loaded in at the start. So when we go right here and we go movie, and I don't have it loaded in. So I don't have it loaded in either. So load everything in from the data file, and I don't have it loaded in. Well, that's a problem, right? Is it a data set that needs to be loaded? There we go. Okay, so to load movie, you need to do, I'll put it in the chat, only run this one time. What I'm putting in the chat right here, only run this one time. Run this one time. And then after you run that, you can go here to library, and you do library reg class. And you know reg class is installed if it appears this way right here. So if reg class appears this way, it does work, and we have it installed. So let's go ahead and run reg class right here. And now we have reg class loaded. So, oh, thank you, Mohammed. You are awesome, Mohammed. You are awesome. Let's go here and do data movie, and that loads the movie data frame in the classes of the first 3 columns of the movie data frame. So now data frame can be used. Let's give it a shot right here. Apply, and we're going to put in the movie data frame, and then the function we are going to do to it is the class function. So we're going to go here to class, and this will give us the class of the first 3 columns. Now, we don't have to worry about kind of limiting this because the movie data frame only has 3 columns in it. So what can we do? We can then unlist this, and unlist takes a list to make it into an unlist. So if you have things in a list, unlists it, and turns it into a vector. So let's look at the original output right here. You'll notice that we have the original output as a list. Ah, yes, Emily, great job right there. Glad we got it working. And we've unlisted it, and then it wants a table right now. It says the classes, or a frequency table showing how many columns of movie are this, this, and this. We can actually use this output right here, and I think this will work. You know, sometimes you think something will work. That works. So we just took our output from 5B, and we put it inside of a table, and it works perfectly. That's what we do. We take the output right there, and we just put it inside of a table, and since it's treating it as a factor, it instantaneously does all the work for us. So amazing stuff right there. Really, really good stuff. Let's take a look. I think the other question was, got to look at the questions. Wasn't it 3? 3B. 3B is the one we're going to do next right here. Let's take a look at 3B. Print the contents. Oh, wait, might be more of this. So we have to do some other stuff right here. We need to make the BAS vector. We need to make the BAS vector, and let's take a look at the BAS vector. Probably one of the best ways to make the BAS vector is to take the following data and just store it in there. So with this right here, we basically have it. We basically have everything we need, and then we're just going to make it look better. So we need the log 10 of this. And let's do that. Log 10 done. The cubed root of this. What do we do to make things a cubed root? We'd go right here, and we'd raise it to the 1/3. So that'll do the cubed root for us. If you raise it to a negative power, it flips it upside down. If you raise it to the 1/3, it does the cubed root, like 1/2 would do the square root. 1/3 is the cubed root. Now, I think where people make mistakes is with the E one, because E is not inside of R. We have to do EXP, and that is a function that'll raise E to the following power. The last but not least thing is negative 2020, and we got that because 2020 is a sad year. 2020, not a good year. Coconut Red Bull. Connor knows what we're talking about here with Coconut Red Bull. We got some Coconut Red Bull. Always Coconut Red Bull. So we have the BAS vector right here, and it is created, has the values. Make sure it's a quantitative vector. So we have the quantitative vector right here. The drink this semester, Connor, has been cold brew, Starbucks cold brew. There's a sip in it left. Good stuff right there. Good stuff. So since these are bogus values, I think this is where people get tripped up. We're saying 1820 and negative 2020 are bogus values. Now, probably the easiest way to deal with this is to store a vector of bogus values. And let's store into the vector of bogus values those values. So if you notice, we've created this vector of bogus values. Ah, I think you're seeing, oh, you're telling me it's Starbucks maybe right here. So now the question becomes, can you please go over 1B and 1D? Yeah, let's take a look at that right there. You bet. We'll do 1B and 1D. I need to grab the equations for those too. So the bogus values right here are values that we want to replace. Now you could simply look at the vector and find where these are at. This is like position number 9, I think, and this is position number 5. And so we know what the code we want to return should return. We want it to return 5 and 9 because it should identify whether the values in BAS are contained in the bogus values. So notice how this returns falses and trues, but then what do I put this inside of to make it return the positions, which actually you don't need to do for this. And I'll show you. Because technically, you could go to the BAS vector and use the wrong type of parentheses. That's what you could do. And we have that this returns the values. So the which is not needed. I think it's good sometimes, but you could have this return with the which the positions of the things that meet the conditions. So this right here, Connor, I think you and I have the same taste, like coconut Red Bull, Starbucks cold brew. That's what it's all about right there. And now that we have this, we're one step away. Yep, Connor's got it right there. Yep, and that's the other way of doing it. And so I didn't realize for a long time that you don't need the which. Not that it's a bad thing, but this will return the same values, right? No, you're fine. You can leave the code in the chat. So this returns these same things right here. And now we just store into those positions. So storing into those positions right here does obtain exactly what we are looking for. So we are able to obtain this, and yeah, that stores into those positions. I think someone was asking about 1B and 1D. Let me go grab those real quick right here. Let's go grab 1B and 1D. And so 1B and 1D. Oh, I got them right here. Perfect. 1B and 1D. So this is, oh, there's lift and everything. So 1B and 1D. Now, everyone knows how we code. Everyone knows how we code. We code in little bits. Connor knows about that right there. Coding some little bits. Yeah, I didn't know it either. You could leave out the which. That was the craziest thing to me. Like, oh, you can leave out the which. It works. Works 100%. It's like, wow, who would have thought? So with this right here, we've got that we're doing 1B, and you need to break this into parts. You can't, don't just write that whole thing. Don't go about writing that whole thing. Don't do that. It'll not work. Very, very bad. I would start by taking as small as little bits as we can. I'd start with this. So let's go to a new RMD or new R script, and let's code that a little bit right there. You know what we're talking about here, little bits. So we've got 3 plus the square root of 2. Boom. Look at this. 3 plus the square root of 2, done. Done. Now what do we need to do to that? Now we're going to go here and code the log 10 on it. So now we're going to code the log 10. Connor's about to put the whole thing in the chat. I love it. And now we've got the log 10 of it right here. So we've got the log 10 of it. And now we're just one step away right here. No. Little bits. That's how we code, little bits. Little bits. That's how we do it. You know what you can do? Watch this. I'm just going to call this whole thing right here X. I'm just calling that X. Does that make sense? I'm calling that X right now. So I'm just going to go here, and I'm going to store this into X. That whole thing is now X. Does that make sense? That's now X. And so the bottom of the equation, if you saw it, was X plus 1. So the bottom of the equation is X plus 1. And I feel confident enough. I don't know. We got to do a little bits, right? X plus 1 is that. And then I'm going to put that into parentheses, and I'm going to go 3 divided by. So now what have I coded as you take a look at these steps as we code in little bits right here is I've coded everything right here. So be very careful. I think people put, they don't evaluate this first. And so this all needs to evaluate. Will this evaluate the same? Good, it does. But we have here the log 10. So I just put an extra parentheses. Be like, you evaluate, you do your thing. And now we go and we see that we need to do ln 5. Now, how do we do ln? You know what you could do? You call this y now. You can keep kind of simplifying and making things smaller, just easier to deal with, because I think if we do that, this whole thing is now y. I wish I had a different color, but it's now y. That looks really bad. But that whole thing right there is now y. because it's everything inside of here. So everything inside of here is now y. But how do I do the whole ln 5? There is no ln, so I have to do log of 5, which is actually the natural log. And I think it was it minus y or plus y? Let's take a look. It was plus 5. And that's got it right there. We have now done this whole part right here. So that's the natural log, because this is natural log. If you don't put in a base, it does base e. Just to confirm, we could put in exp1, which is base e, which is 2.7181828184590 2.71828. Yes, exactly. 281818. All that good stuff. There it is right there. Same number, confirming that we've done it. And then we're going to take this, and I think we might not need to simplify further. It might cause confusion. We're going to take 2 divided by that, and we're going to do 1 plus it. And that is how we code in. You got it right there. And there's our answer. So that's what we do, is we do it step by step. Be very careful. It's very easy to make mistakes. Kind of look over your work in those little bits and make sure you get the right answer. Just follow along very slowly, step by step by step. And that should be the right answer to the following question. Let's take a look. Going back to here. What do we have? So I think D was the, oh my gosh, look at this mess. What do you think we're gonna, yeah, I know, right? No, this is Amber, you're right, because I used to do the same thing. I used to write out a bunch of code and then it didn't work. And I was like, well, I don't know where the error is at. No, I mean that. Like, you write out a whole bunch of code, it doesn't work, and you're like, well, I've got like 10 spots to check right now. And you're like, well, somewhere's broken. So as you go step by step right here, you'll notice if you make an error and it'll say error and you'll be like, okay, I made a mistake. So where in this, look at this, awesome stuff. What do you think we should do first? What do you think we should maybe do first for our little bits right here? What do you think we should do first? We could do the top of it, top part. That wouldn't be too bad to code. We call it X, call whatever we want. Mine ends parentheses. It might, you could send it to me, especially, send it to me via email or Discord. And yeah. Yours ends with all the parentheses. It can if you think about this. This is X right here. So this is, here, let's do this. Let's copy this code. And this is what X is. So this is what X is right here. And then this is what Y is. There we go. So this should give the same answer. There we go. It did. And and we've done it. So this is the way it can look also. So you want to do the numerator? You got it. Let's do the numerator right here. So the numerator is going to be the easiest thing to code right here. 7 minus 2 times the square root of 2. So I'm just going to code for the moment. 7 minus 2 times the square root of 2. And that's good. And then we're going to do e raised to it. Boom. Done. Numerator done. And so 2 times the square root of 2. So yeah, if you do 2 times the square root of 2, but that shouldn't be, because square root of 2 times square root of 2 is 2. So is that right? And that's exp of that. So that's what power would you raise? Oh, because it's like a, let me check this out. Let me look at this. And this minus it. Something seems off. Exp, oh, it's e raised to that. I was thinking log still. I was still in the log mindset. It's exp raised to that. It's e raised to this right here. And e is a little more than 2, so we get something around 64, which is interesting because 64 is like multiples of 2s and 4s. So we've got that first part coded. That's exactly what we wanted to do. First part is coded, and now I'd probably handle this chunk down here. And you can call these things whatever you want. Be careful if you overwrite things, like I'm just going to call this x again, and I'm going to call this y right here. So we can just kind of section it off because it's plus this, so it'd be plus y. So for all intents and purposes, this is now x. And we know we have it correct. Like, we always just kind of be like, okay, we've got this correct. We've done it. And now let's go here to y and do 2 minus 0.5 to the 12th power. So we kind of use the same thing right here. 2 minus 0.5. And that was to the 12th power. Was it really to the 12th power? Let's take a look. Where's that thing at? Square root of 12. Square root of 12. Very similar. And so this right here, please tell me if I do something incorrectly, because this should be the right answer right here. And now that's our y part of it. So we've really taken this apart. And now I'm going to code this right here. And we're just going to call this z for the moment. just to make our lives easier. And that's really the big chunks of it. So this is z, and this is 2 times the log 10 of 20. So z is 2 times the log 10 of 20. I think we've got it. We're really close on this one now, because now we just have to do 1 plus the absolute value, 1 plus the absolute value, and let's take a look at that, of negative 10 plus z plus y. Negative 10 plus z plus y, that's the denominator. And yep, that's the denominator. And then here's the numerator was x. And I think that's got it. Oh no, I didn't put the thing. That's an error. It's an error. We got the right answer. Plus errors. Wrong sound effect for error. We need the oof. Oof. So 28 errors. Constantly making errors these days. But I think that's got it. Is that the answer other people are getting? I am capable of making mistakes. We don't want to get too many errors on this. But that is the equation coded in. You could code the whole thing. I like doing little bits because that way we're less likely to make mistakes. What does everyone think? Did I do it correctly? Is it 1 plus? Let me look. 1 plus the absolute value of negative 10. Let's look at it at the same time. 1 plus the absolute value. Awesome. Tell me if I got it wrong, because I'm capable of making mistakes on these. 1 plus the absolute value of, and then z looks to be accurate, 2 times. It's easier to look at, too, because you can kind of section it off here. And as long as I didn't write things incorrectly, which, like I keep saying, I can do. I make mistakes. I write things the wrong way. I do it all the time. So if you see any errors, please tell me, and hopefully I'll be like, that's what you got. Right there, we got it. We got it. Which sound effects? This is little bits. It's alert. So it's right. Perfect. What other questions are there? We'll probably do at least 1 or 2 more questions, but what other questions are there? What other questions are there? Could you try 4H? You bet. 4H, let's do it. So let's go down here. And here, let me get the homework up. 4H. Okay, 4H. And when we get to 4H right here, 4H says only the elements that are multiples of 5. So the first, this relates to an earlier question of with sequences, and then we'll do 2B. You got it, Sylvia. So 4H, how do we deal with a sequence? And first, let's make this sequence going from 5 to 35. I cannot speak today. So we want to look at ACT scores that are only contained in, that's a huge hint, the sequence 5 through 35. So we want to look at ACT scores. I'm going to write in the chat. ACT scores that are contained in a sequence starting or from, from 5 to 35 by 5. So that's a huge hint. ACT scores that are contained in a sequence from 5 to 35 by 5. So be thinking that over as I go down here, and I think I still have the education data set loaded in. So we need to go to, or is it ACT? Yeah, we got ACTs. So ACTs that are contained in, there's contained in, if I could spell it properly. It had the right coloring. It might have worked, who knows. So ACT scores that are contained in the sequence, and I prefer sometimes to use this from to, sure, why not? Yeah, no space today. 235 and then by 5. Think about what the output might be. You got it, Sylvia. We will do those next. Think about what the output, or Isabel wants them too. Think about what the output for these might be. Who knows what the output for this might be? Like, think about what this will return right now when I run this code. What's in what's is, because it's a percent in percent. It'll tell me with all of these ACT scores whether it's contained in the vector. And look at the last one. It's 25. What was the first one? The first one was 25. So all of these right here will return what's in what's is when I run this code. It's asking, are these ACT scores here contained in this vector? So what will the code return? The last one's 25. So this will return trues and falses. And since the last one was 25, it was contained in the vector. Remember those first few ones right there? Well, they were contained in it also. So we see right here that the values, yep, trues and falses, we got it. And I think, are we just taking the median? Only those elements, and we're doing the median of these elements. Well, check this out. You can just call this interest. This is maybe a good way to break it up too. is we could go here to interest, we could go to ACT and only select the elements we're interested in. Notice how we only have the values of ACT that are contained in the vector 25 or 5 through 35 going by 5s. So now this vector right here only has the values we are interested in. So this up here gets us the positions, and if you want, there's an additional step, unneeded, but you could put a which around it. The which is going to give you the numeric positions, which does the same as the logical. So if you're seeing this is the same output, the which just gives you the numeric positions, but the logical vector will still select those positions. Now that we have this, we're one step away. Just do that. And people were asking earlier, how do I do that? I select my code and I just do Shift 9, and there we got it right there. That's got the median. Boom. And then 2C and 2B, and I think we have just enough time. We got this, 2B and 2C. Let's see right here, 2B and 2C. Oh, I love 2B and 2C. It's great questions. So the sequence stuff I think we're pretty good on, but here we go with writing functions and doing vector mathematics. So let's generate a sequence right here. What do you notice about this bottom number? It's 2 squared, 3 squared, 4 squared, up to 10 squared. So what's really crazy is, can anyone write the sequence of numbers very quickly, 1 squared through 10 squared? How would you, we'll just do this first. Put in the chat right now if you want, 1 through 10. Put in the numbers 1 through 10. Put the numbers 1 through 10 in the chat. Who knows how to do that? Just to make 1 through 10. Just to make the vector 1 through 10. How would we just make the vector 1 through 10? That's like the start of this question. Just think in little bits. Everyone knows right there. We code in little bits. So first we're going to make the vector 1 through 10. And then we'll make the vector of numbers 1 squared through 10 squared. So the first objective, make a vector of numbers 1 through 10. And I'll give away the answer right here. Vector of numbers 1 through 10, boom. And now, second objective, make a vector of numbers 1 squared through 10 squared. And so if you square this vector, you've got 1 squared through 10 squared. Now we don't want 1, 4, 9, 16. We want to take this and do 1 divided. You know what? There's an easier way, isn't there? There's an easier way. Just raise it to the -2. So now if you notice, these are the numbers we were looking for, because we were looking for, oh, maybe it's not. It's third power, isn't it? Someone's got to correct me here. Third power. There you go. Third power. So now it's 1/8 and 1/27 and 1/64. No, that's not right, is it? Is it? It's 1/64 and then 1/25 and then, oh no, 36 times 6, 1/216. 7 times 49. That's not that bad. Is that 1/343? I have to know. Yeah, it is. So that's what we got going on right here. We've created the sequence of numbers, and now we need to find the sum of it, I believe, and then find out what that is as a fraction. So we're really close. We just take this sequence, put a sum around it, and there's the sum of it. It's basically a little bit more than 1. And then we take this sequence, or we take this number, and we turn it into a fraction. Now people say, is this fraction reduced? And I believe it is, because you could take a fraction like 12/8 and you see you get 3/2. It's just a ridiculously kind of weird fraction. So you can get the fraction, it'll reduce it. And so R can do all these nice things. It can reduce a fraction for you. There might be even an additional argument inside of fractions like don't reduce. Cycles, max denominator is 2000. Whoa. So, and I don't know what cycles is. So if we go here, don't do this. Max denominator equals 100. So that's the closest fraction to it. Watch this. This will be 2/2, I bet. It'll be 1, because yeah. So it rounds it. It finds the closest. That's kind of a neat thing about this. Like if you're like, I don't want any fractions bigger than, like that right there. It'll give you the closest fraction. I didn't even know of this additional argument. So you could be like 1,000. And that's the, whoa, wait. That really went haywire on that one. It's the mass package right here, which I believe people should have. I think mass installs. Here we go. Right there. There's mass, and it's the mass package right there. So that should have it. And I guess it kind of went haywire when I put it that high. Huh. It breaks after 100 and just... Does it break right at 100? Where does it break? Somewhere around here. We're almost narrowing it down. Up, right around here-ish. Nope. 136. Why does it break? Why does it break at 136? That's so weird. How the max denominator only goes up to 136, and then you can't. So weird. Interesting. Now we have here, that was 2B? Was there a 2C? I don't see 2C. Was it on 320? Isabella, maybe I missed it. Might have been a 321. I'll go grab the 320 assignment over here. Let's go take a look. Oh, cool. I got added to a class this morning. Time series. My goal is to eventually teach time series. Connor, if you're still here, I am an observer of a class now. I am an observer of time series. And I'm probably going to try to watch those lectures this weekend. And I'm going to try to learn. And my brain will grow. It's not that I don't know time series. I've just worked with time series so intermittently that I don't really have good knowledge of time series. So not that I have bad knowledge, but I can't teach this class right now. You don't want me teaching time series. I'll tell you things that are incorrect. Your sequences will be things like, let's say it wants a sequence from 5 to 100 going by 2. So the orders for sequences is going to be from equals 2, if you just want, 2 equals 100, by equals, and whatever you want the by to be. I believe so, Amber. Yep. So understanding these small differences between the sequences here is the key, because we have additional things we could put in here where length gives you that many elements. So I think where people get confused, Isabella, is going to be that if you want so many elements in a sequence, you can make sure to give it that many elements. So let's say I set a sequence from 2 by 4 with a length of 2. So what will this sequence print to the screen? The more you can kind of understand what the code will create, it'll help figuring out what it is. What will this create right here? What will this create right here? What will this create right here? A sequence from 2 by 4 with a length of 2. A sequence from 2 by 4 with a length of 2. What will that create? What will that create? Any ideas on what that'll create? So it'll go from 2 by 4 with a length of 2. So it'll start at 2, and it'll go by 4, and there'll only be 2 things in the sequence. You got it. Yep. So the length of the sequence is how many things it creates. Nice job, John, right there, 100 points. So the length of the sequence is how many things it creates, and this only creates 2 things in the sequence. So we have that right there. I'm trying to think what else, because this right here creates a different sequence, and it's important to know these different arguments. Now, something you can do to really help out is you can always go over here to the question mark sequence, and it'll explain to you how to use sequence. So you can always do question mark on any function you're working with, and it'll explain to you how to use each sequence. So definitely look through this, ask questions, but this is the big stuff, and we're getting near the end of office hours, but really good stuff today. Did people get some questions worked out? Did people figure out how to do a few things today? Got some questions finished? People feeling good about the homework assignments? How are we feeling about those homework assignments? We got the graphics error right here. No. There we go. No graphics error. How are we feeling about those homework assignments? Feeling pretty good. We will see. Because I'm probably going to answer a few more. How do I delete a chunk? To delete a chunk, hover over the chunk, delete. That's how we delete some chunks right there. So to delete a chunk, you can delete it. You can also make it so the chunk does not knit by going to show nothing, don't run code. Be careful though. This will add an eval false and include false. Eval means the code does not evaluate, which means it just doesn't go to R's brain, and then include means it won't be included when you knit it. What do you want us to knit to? Word docs. Word docs. Good questions right there. Pretty good. Feeling better. A lot of work, but everyone is doing a great job. And I think really good office hours today. I think, is this my 2-hour office? Wait. Might hop over to the Discord. You're welcome, Jake. I'm going to hop to, because I've been getting a ton of emails today. So I'm going to hop to the Discord, say hey, and I'll be working on some more stuff. You're welcome. Keep asking those questions. If you are not on the Discord, join it and send me the email and say hey. But I'll be back. Sorry, I went a little short today, hopping around, a lot of emails, a lot of great work. And if you're stuck on a question, email me immediately. I've got a lot of videos up on how to do everything, but we'll be back. I'll be streaming a little bit later doing class. I will see everybody here in a little bit. Bye for now, everybody, on this 20 Point Tuesdays.